It's never a dull moment in the world of tech, especially right now. It's only been a couple of days since the CrowdStrike outage brought down a good chunk of the business world. In this episode of Global Nerdy, we'll look at what CrowdStrike is, what happened, and what the future is.
A worldwide IT outage has crippled travel, impacted bank and credit card transactions, and even affected some medical providers today. According to Microsoft, the software update from a company called CrowdStrike triggered this problem.
All sorts of applications run using CrowdStrike to protect them from malicious attacks and hackers. The problem is what happens when the security system itself has a bug. Who are CrowdStrike? They are a cybersecurity company that was established in 2011, and they've made a name for themselves doing some very interesting investigations, including finding 5 Chinese military hackers and charging them with cyber espionage against US companies. They found Energetic Bear, who have ties to Russia's FSB. That's what replaced the old KGB. If you ever watched James Bond movie, they were the bad guys. Energetic Bear was a group performing cyber espionage against worldwide companies, particularly in energy. They also found that North Korea was behind the Sony Pictures hack. Also, the Democratic National Committee email hacks that took place around the time of the 2016 US elections. It was found that the 2 Russian cyber hacker groups, APT-28 and APT-29, better known by their more memorable names, Fancy Bear and Cozy Bear, they had hacked into those systems. And a similar hack was also performed on a Ukrainian artillery program, which led CrowdStrike to conclude that, yes, that was also a Russian attack. In fact, there is a conspiracy theory spread by less than truthful groups such as Russia Today, Sputnik, and Breitbart News that it was CrowdStrike who were hired by the Ukrainians to break into the Democratic National Committee servers and make it look like the Russians did it. This conspiracy theory has been disproven several times. More recently, if you were talking about CrowdStrike, you were probably talking about CrowdStrike Falcon, their anti-malware application. It's used by more than half the companies on the Fortune 500, including Google, Amazon, Intel, and quite possibly your bank, grocery store, and the airline that canceled your flight on Friday. For the purposes of this discussion, I can simply describe CrowdStrike Falcon as an enterprise-class anti-malware application. Think of it as a big-time version of Malwarebytes or McAfee. Here's a high-level view of how Falcon works. Imagine that these Among Us characters are processes, that is, mini programs spawned by the applications you're running on your computer to perform tasks such as recalculating a spreadsheet cell, displaying a graphic on the screen, or saving a file. Modern anti-malware protects your computer by watching the behavior of these processes. If a process behaves suspiciously, well, then the anti-malware application kills that process, removing the threat to the system. So what happened on Friday, July 19th then? Well, that calls for a little background explanation. First, let's make sure you know what an operating system is. Simply put, an operating system, or OS, is the software that tells your computer how to be a computer. The OS's job is to manage the processes running on the computer, manage the active memory, that's RAM, the long-term memory, that's file storage, like your hard drive, and any hardware controlled by or attached to the computer. You can view your computer as a set of layers, where each layer relies on the one below it. The lowest layer is the device layer. That's your computer, smartphone, tablet, smart TV, or any device that has a processor. The only software that's typically built into your computer is the BIOS, the basic input-output system, and its primary job is to load the next layer, the operating system. The operating system layer, being directly above the device layer, is in direct contact with your computer and manages its inner workings. To To repeat what I said before, it's how your computer knows how to compute. Above the operating system layer are your applications. Just as the operating system needs the device to run, applications need the operating system to run. Applications running on a device don't have direct access to the device hardware. Instead, they control the device through APIs exposed by the operating system. These APIs include things like graphics APIs, file system APIs, networking APIs, and so on. And finally, there's the layer above the applications, the user layer. You interact with the device through its applications, which in turn do so through the operating system. Now that we've covered operating systems, it's time to dive a little deeper. Central to the operating system is the kernel. That's a word that means the central or most important part of a thing. In an operating system, it's the core component and in charge of the OS. It acts as the coordinator and the main interface between the computer's hardware and the processes running on it. Remember, the processes are spawned by the applications in the course of doing what they do. Operating systems divide a computer's memory into two spaces. The first of these spaces is called user space, which some developers refer to as Userland. Userland sounds a lot like the amusement park that calls itself the happiest place on Earth. Because anything can run in user space, I think of it as the happiest place in the operating system, and that's why I like calling it Userland. Userland takes up the majority of memory and is for all code running outside the kernel. This is where your applications and their data live, as well as any libraries that the OS uses to interact with the kernel. Like I said, the happiest place in the operating system. In Userland, each application is cordoned off into its own memory space and normally can't access any other application's memory space. This cordoning off means that if one of the applications does something goofy and causes itself to crash, it doesn't take down any of the other applications with it, and the operating system and other applications carry on as if nothing had happened. The other space in memory is kernel space, a much smaller portion of memory reserved for running the kernel. The code running in kernel space is generally restricted to these three things. 1. Managing processes, 2. Managing memory, and 3. Managing devices. Since the kernel is central to the OS, when something goofy happens in its code, it deliberately goes into a failure mode so it can't do anything harmful to any applications, devices, or data. In Unix-based operating systems like Linux and Mac OS, this failure mode is called a kernel panic. In Windows, you experience it as the blue screen of death. Because the kernel performs crucial tasks, only code with the appropriate level of privileges can run inside it. Most applications by third parties, that is, code by developers who didn't make the operating system, don't run in kernel space. As you might expect, there are exceptions to the no third-party applications in kernel space rule, and one of them is device drivers. Device drivers are mini applications that tell the kernel how to connect and interact with external devices, such as graphics cards, printers, and other peripherals. You've probably experienced the quote-quote joy of searching through the internet to find the right device driver to get something to work with your computer. Device drivers have privileged access to the kernel, the most sensitive part of the operating system. Because of this, they're usually digitally signed by their developers to prove that they're really device drivers created by the device manufacturer for the device you want to connect to your computer. As an additional security measure, device drivers for Windows are often digitally signed by Microsoft after going through their testing and approval process. It's like having FBI or Secret Service clearance. Enter CrowdStrike Falcon and one of its applications, Falcon Sensor. Its job is to look for suspicious processes, and these days, detecting malware means being able to have a complete picture of the operating system, and that in turn means knowing what's happening inside the kernel. In order to do this, Falcon Sensor has to operate in kernel space. So it's written like a device driver, even though it doesn't connect the kernel to any devices. Like a device driver, Falcon Sensor is digitally signed by Microsoft and goes through their testing and approval process. But here's the difference. A device driver is software that connects the kernel to a device and is released whenever that device is put on the market. Devices are physical objects, and manufacturers generally don't put out more than a couple of models in a year. It just takes time to make stuff. That's plenty of time for Microsoft to approve a device driver. On the other hand, rapidly evolving software like malware calls for a rapid response, and you want anti-malware applications to be rapidly updatable. Falcon Sensor runs like a device driver, but the device driver approval process is too slow. You want to be able to update it as soon as new kinds of malware are detected. The solution is to not update Falcon Sensor, but instead regularly send it configuration files called channel files. These files contain data about malware behaviors to look for. As configuration files, they're technically not code running in kernel space. They merely configure how Falcon Sensor looks for malware. Falcon Sensor is the code running in kernel space and has been improved by Microsoft. Of course, if there's something wrong in one of the channel files, then that channel file can affect the behavior of Falcon Sensor, and Falcon Sensor, as software with device driver privileges, can affect the kernel, and that's what can lead to the blue screen of death. Last Thursday, July 18th, 2024, CrowdStrike pushed out a new channel file to its customers. This channel file would define how to handle cases where malicious applications were using named pipes within Windows. That is, a communication method for processes within Windows to talk to each other. Anyways, the problem is something was terribly wrong with those channel files. As I said earlier, if there was something wrong or goofy with the channel file, it would affect the CrowdStrike Falcon driver, which in turn, because of its close connection to the kernel, would affect the kernel. And that is exactly what happened, and that's what led to the blue screen of death. As if things weren't complicated enough, Falcon Sensor isn't just a kernel driver, but a boot start driver. As you've probably guessed from the name, it is a driver that must be up and running in order for Windows to complete booting. Now, of course, because it fails to run and crashes the kernel and sends Windows into the blue screen of death, Windows never ever boots up. And without an operating system, as I said earlier, the computer does not know how to computer. Of course, since the computer does not know how to computer, it means that you can't fix it remotely. You have to get up close and personal in order to fix it. And the way to fix it is to boot it into safe mode. Now, for those of you who aren't familiar with safe mode, let's talk about the regular Windows boot mode first. In regular mode, what basically happens is that Windows boots up with all sorts of drivers and systems extensions and all the goodies. The problem is you don't want that when you've got a faulty kernel driver like you do with CrowdStrike. So you boot it into safe mode. Safe mode is basically just enough operating system to get the computer working, just enough to run programs and look at the file system. It doesn't even give you network access unless you specifically say, I want to boot into safe mode with the additional feature of network access. According to CrowdStrike, what you should do is, once you're in the system in safe mode, go to the Windows directory, then go to system32/drivers/CrowdStrike and find all the files that begin with C-00000 0, that's 5 zeros, then 291, and have the .sys, that is system files, file name extension. Pick those files, delete them, then restart the system. Once you've removed those defective channel files, Falcon Sensor will stop acting goofy and will stop crashing the kernel, and you will be able to boot the computer back into Windows and you will be up and operational again. As if that weren't enough, there is one more wrinkle, and that wrinkle's name is BitLocker. As in the drive encryption system that Windows provides, to boot into safe mode, you will need to enter the BitLocker recovery key in order to unlock the drive so that safe mode can boot. The problem is you'd better have the recovery key handy, and in theory, either you or your sysadmin should have that key. In practice, doesn't happen all the time. Best of luck. Alright, let's get the easy predictions out of the way. Very quickly, they are a stock price drop for CrowdStrike, class action lawsuits, people considering going with other solutions, and finally, my new favorite prediction for every time something this major happens in the technology world, and that is Elon Musk says something dumb. There's going to be a lot of reviewing among various tech groups over the next weeks and months. Starting with IT groups and operations groups, they're going to be looking at their disaster recovery procedures and looking at ways of making them less manual and looking for weak spots, such as perhaps not having the BitLocker keys handy. That took down a lot of people. Developer teams, of course, are going to be reviewing their testing procedures. DevOps teams are going to be looking at their rollout procedures, perhaps a canary-style rollout where you don't automatically push software to everybody, but a small group at a time and see what happens would be a better way to approach it. And then finally, CIOs will be doing some reviewing on what it means when key parts of your infrastructure are being outsourced to vendors. That's going to be a tricky thing because at the same time, around these times, CIOs are also getting the order to cut costs wherever possible, and outsourcing seems to be the way to do that. Just a couple more things worth checking out. The first is the July 23-24 edition of Gergely Oroz's newsletter, The Pragmatic Engineer. By the way, a worthwhile read. Anyways, he does a thorough review of the CrowdStrike incident and lessons that developers can take from it. The most interesting idea in this piece is to start thinking of configuration files as code and not just as merely data that our code uses. The other thing I'll point you to is this tweet by Scott Hanselman, who is Microsoft's VP of Developer Community. Let me just read the back half of his tweet, which goes like this. It's always one line of code, but it's never one person. Implying inclusion policies caused a bug is simplistic, reductive, and racist. Engineering is a team sport. Inclusion makes for good teams. Good engineering practices make for good software. Engineering practices failed to find a bug multiple times, regardless of the seniority of the human who checked that code in. Solving the larger system thinking SDLC matters more than the null pointer check. This isn't a get good, C++ is hard issue, and it damn well isn't a DEI one. I hope you found this both informative and entertaining. I'm just getting this channel started out, and I would appreciate it if you hit the like and subscribe buttons. I'm Joey Davila for Global Nerdy at Cheat Codes for Tech Life. Thanks so much for watching.